All right, everybody. Thanks for joining us today for our June ROS-Industrial Community Meeting. I'm your host, Matt Robinson, and let's get to it. Here's today's agenda. So I've already welcomed y'all, so we're off to a great start. I'll go through some at the ROS-Industrial level updates. I'll kick it over to my colleague, David Spielman, who's online today to share a few tech updates around, probably largely around Scan and Plan Workshop. And then we have two guest speakers today. Orbeck, robotics update for ROS-I community. Brad Sussmith is here from Orbeck, and then Mark Bestman from DLR is here to share some work they've done with Reach and adding some ability to optimize by merging with Optuna. So in that case, we'll hopefully have some time for some just discussion. I think first off, for those of you that supported the ROS-Industrial annual meeting, thanks for coming out. For those who aren't familiar, each region, and as part of the ROS-Industrial network of consortia, host a big annual gathering. And ours was March 27th and 28th. We hosted it here at the Southwest Research Institute campus. Thanks to all those that made it for day one during the tours and whatnot. We probably, believe we checked in around 88 people. And then it was members only day two. But overall, it was great to have a bunch of live demos. The attendees could interact with the developers. So it was a very different type event than we hosted Automate. But we'll be back at Automate in 2025, and we look forward to having some demos basically baked into exhibits at Automate. So stay tuned, and also some more info. I'm still digesting some of the output from both the networking and road mapping with the members, and then road mapping with the regional consortia. So stay tuned for that. There's a big update coming. As far as training and education, the big thing I wanted to highlight is we have a training event July 16th and 18th in Wichita, Kansas. This is hosted by ROS-Industrial member Spirit Aerosystems on the campus of Wichita State in collaboration with NIAR. We'll be focusing on motion planning optimization. There's still a few seats left, so if you're interested, check that training out. Again, we allow full members to host a training event, and this helps us because then we can actually have these training events in other places other than San Antonio, which can be beneficial for depending where members are located. So we're hoping to get something a little bit farther on the eastern side of the country in October, so stay tuned. We had some notional volunteers to host training. We're just gonna iron out the details, and that may come together. We'll announce it. Either way, October training, worst case, happens in San Antonio. But fresh off the presses, I think last week we got notified that RIC Americas submitted workshop on toolpath planning. So this is largely leveraging the open source repository Nether, has been picked up. And so on day 0, as they call it at ROSCON in Odense, they do workshop day. So stay tuned for this toolpath planning workshop, hosted, I think it'd be put on by Michael Rippiger and someone who works with him. And this is from Michael's Reach workshop last year in New Orleans at ROSCON. So we look forward to, again, following up. And of course, Scan and Plan workshop, you'll hear a bit more about later. But there's the GitHub repo. There's been a lot of commits lately to that repository. The big thing at a program level I wanted to share is that we've been obviously feverishly, yeah, this video is going to be a little herky-jerky. We'll just pause that. Robotic Blending Milestone 5 concluded. We had a final demo on March 7th. We had a kind of program wrap-up at the end of March and submitted final documents in April. But since then, there's been a lot of activity. There's been some commits and improvements to Nether, the toolpath planner that I mentioned previously, as well as Scan and Plan Workshop, which David will go into a little bit more detail. The interesting thing about these collaboration projects is it brings together many different team members. In this case, we had Yaskawa, Push Corp, ourselves, and of course, Steel Founder Society and their partner, University of Iowa State, which they've been funding quite a bit of work with. So it was really great to work with a university that has like really good practical manufacturing chops, but then work with them to take what they develop and enable it to be leveraged in a modular robotics framework. And that learning still and collaboration continues. You can see here a number of the different hardware components. PushCorp and Yaskawa provided some tools. In this particular application, it's leveraging the RealSense 455D. We haven't blown one up yet. You can see it's got some protection, but being a foundry, you might wonder, but actually it's been going all right so far. We do have basically the same robotics framework running in 3 locations. We have an instance here in our lab. You can see in the center image the ISU implementation on a Kawasaki robot, and then the production system running in the upper right at Fisher Cast Steel. And this is really useful, right? Because anyone makes commits. We basically have different hardware sets. Our PushCorp grinding system is a little bit different than what the other 2 sites have. Obviously, ISU is running a different color robot. And so it's really interesting to be able to kind of cross-test across the multiple sites. And that's really interesting in these collaboration projects. In this particular case, we stepped through, and David will probably touch on some of this. There's been a really neat, the selecting regions, for instance, has been updated. And so hopefully David will be able to touch on that, as well as some of this notion of submeshes. As far as like, hey, making sparks, we were really excited to be able to say like, hey, we can mark a region. The person can see it in the scan and select that or trace over it, because we never really got the automatic segmentation working robustly. We're still, like, again, helping the university iron that out. But you can see here, we're able to basically stay within the region boundary with our other segmentation tools. So that's been really encouraging. In this implementation, where you can like basically draw on the mesh, the reconstruction is in Scan and Plan Workshop, so you can experiment with that yourselves. It's just another video of grinding happening, right? So here you can see it's processing inside the selected boundary, which is kind of what we're shooting for in this particular case. And it took a little bit of tuning, working with these particular stones on making sure like, hey, I want to have like, say, a 5-degree drag. How do we ensure it stays in the boundary as I change that drag angle, or in certain cases, a push angle? The foundry is continuing to investigate angles. And so like making sure wherever we're contacting on that cup, that stone cup, honors the boundary is sort of baked into the toolpath planning. So that's been pretty exciting. So again, just shout out to the team. Here we are working in the foundry just outside of Columbus, Ohio, and West Jefferson, Ohio. So again, a cross-functional team, and we've got the point where the foundry now is having operators, the actual kind of people who do the work day to day, run the system, log improvements or problems. And so it's been now in production since like mid-April, essentially. And so that's a really good outcome. We'll be doing a little bit more road showing about the progress here with partner Steel Founders Society. Their research review is in July, so there'll be some more work coming out on that. But the great news is this is the type of program that makes commitments to Scan and Plan Workshop and Nether, right? So we're getting the benefits impacting open source resources that the whole community has access to. So that's why I highlight it. And again, as we noted, they're almost at the point where they're processing these riser contacts on their castings, beating people, right? So that's what they're really excited about, is the fact they're able to kind of knock these down faster than people can. So this is basically they're chasing where risers, where hot metal has been injected into the mold, they lop them off, and that needs to be ground flush. And so that's kind of what they're shooting for and the progress they're making. So with that said, we can get a little bit more into it with David Spielman. David, are you ready? Hopefully that wasn't too. Hopefully I set the stage for you, man. Do you want to share your screen?
Sure, let me do that. Okay. Okay, do you see my screen?
I do, looking good.
Okay, great. So I'm just going to quickly first go over some of the changes we've made since we completed Blending M5. This is basically what we've done from the start of the project till the end, and then I'm going to discuss what we've done since then. So this is a blog post that I had written up a few months ago about these sort of changes, and I went over it in the developer meeting. So I'm just going to quickly give a high level of some of the updates here, and then go over more in depth about the new updates, which I'm sure is what everyone is kind of interested in. So first things first, we added ROS2 control to scan and plan. So this is really useful in simulation where you can actually see more accurate simulation of how the robot will actually execute during scanning and motion planning. So it's a much easier way to debug robot motion. We also added constant TCP velocity time parameterization, and this essentially allows the robot to move at a constant velocity during planning. Also added Docker images, which can be found on the repo, the ROS-Industrial repo, and that will let basically developers more easily integrate the software on site wherever they are. We've also changed the representation that the collision object can have. So by default, the convex hull is how we represent the collision object within scan and plan. But we've also added implementations for the mesh representation. So it's kind of hard to see in this mesh because the convex hull and the mesh are very similar. But essentially, this allows for a less conservative representation of the mesh in terms of collision. And then we have an even less conservative version of the collision representation, which is the octree representation. And this was particularly useful for blending, where we had to actually model the risers and to make sure that we were actually lopping them off correctly or grinding them off. We needed that extra refined collision representation with the octree. In terms of operation, we've done a few things to make it easier for the operator to see the information that they need to see rather than being overloaded with information. So we've simplified the raster planner, and you can see it over here, to basically only show parameters that are commonly changed during operation. So again, this just streamlines the process for an operator who's not necessarily a robotics expert or familiar with how we handle rasters. In terms of development, we've made the scanning and execution nodes in Python to make them easier to read as well as debug. We've added services for generating scan motion plans, and this is useful to another update that we just made, which is basically allowing more flexibility for custom motion plans, and I'll talk about that a little bit later. We've implemented a behavior tree under the hood, and so essentially what that allows us to do is it allows the developer to more easily see the logic flow of the process in a more graphical way, and allows them to more easily modify how the logic works to their custom application. And we also acted a reactive GUI that works with the behavior tree to basically show and hide certain parts of the GUI during different processes to make it easier for the operator to see only what they need to see. As far as Nether updates go, we've added toolpath and mesh visualization tools that allow you to basically hide and show your original mesh, a modified mesh you might have, and then original and modified toolpaths. And you can see sort of images that show all these visual toggle features in action. Also added a few toolpaths for approaching and departing the part at a specific angle. And finally, we've made a plane project mesh modifier, which essentially projects a plane onto the surface of a mesh and basically flattens it to make sure that you don't reach any inner surfaces while you're planning. This was particularly useful in grinding, where we had certain castings that had inner surfaces that we wanted to avoid while planning. So that's just a high-level overview of everything we've done for the duration of this project. And now we're going to go over some updates that we've made since then. So I'm going to, hopefully this will work. Do you see the presentation now? Okay, great. So what we've recently added is MultiRegion Selection. We've updated the RViz polygon selection tool to basically allow the user to select multiple region on a mesh, extract submeshes for those selected regions, and then create toolpaths on those regions. So this is really useful for a lot of different applications, but for grinding specifically, it was useful for our client to essentially select multiple regions so that they could process them all at once instead of selecting one region, processing that a certain amount of times, and then selecting a different region, creating toolpaths, processing that. And so this really streamlines that sort of process. So as you can see, we've added some numbers to basically show the operator how many regions they've selected. And again, this works very similar to the current RVIS polygon selection tool, except for the fact that you can now select multiple regions and extract multiple submeshes. And so this next slide shows multiple toolpaths generated for each of those regions. So currently we have a single raster pattern that's basically done on each of the regions. We're going to be updating this in the future, but for now, this will work in the meantime. So essentially, once these toolpaths are generated, and again, we're still doing a bit of tweaking on this end to make sure that all the toolpaths are generated properly. Once those are generated, we can then basically generate a motion plan. And here I'm just going through a particular motion plan for these regions. So you can see that once we grind off one of the regions, we can move over to the next region in a similar way that we usually do in Scan and Plan. So that's a really cool feature that we just added. Another feature that we've just added involves a go home function. So essentially what you're seeing here is the robot is halted as it's moving through a scan trajectory. And once we hit the go home button or plan home, the robot will basically plan a free space motion from the point that it stopped at to the home position. And essentially, once you reset the behavior tree and plan again, you can just continue through the motion as you typically would. And I'll just play the video again so you can see it. So we're executing the motion plan, and we're going to halt. So the robot either stops via e-stop or is halted. Then we plan home, and the robot will plan back to its starting state. And this is useful in the case that the robot needs to be e-stopped and it needs to basically go to the home position. This basically streamlines the process of having to manually jog the robot back to the home position or ask it to go to that position via a job file. And what essentially allowed us to do this is we created another service for motion plan generation to basically extend our current capabilities of motion planning. So the way we handle motion planning currently, or before this update, was that we had one single motion planning service that would basically split the motion plan into 3 sections: an approach, a process, and departure plan. Now, in addition to that, we also have a free space plan that's being generated from a current point, the robot's current point, to another current point. So in the case of the plan home functionality, essentially we are planning a free space motion from the robot's stop state to its home position. And that allows us to go from the stop state to the home position fairly easily. Another thing that we've added is behavior tree nodes that further customize motion plans. So we've added functionality to the behavior tree to basically let us add different planned motions to each other in order to create more complex motions. And this is really useful for repeating motion plans. So one of the interesting things that we wanted to handle with Blending M5 project was repeating motion plans. So essentially, instead of previously selecting a region of interest, grinding it, and after grinding, the robot moves back to its home position, we basically wanted to be able to, after the departure plan, go back to the start of the motion and can repeat that process over and over again. And then after a certain amount of passes that we would specify in our GUI, we would then go back to the home position. So these behavior tree nodes allowed us to do that. In addition, with the MultiRegion Selection, we're able to essentially repeat multiple passes on multiple regions within the part in one go, as opposed to having to do it manually over and over again. And then in terms of some more administrative improvements to the repository, we've added package versions and release versions to Scan and Plan to make it easier to track changes that we've made. And additionally, we've added change logs that will basically allow our members and any visitors to the repository to see what sort of updates we've made to Scan and Plan. So yeah, those are the updates we have so far. If anyone has any questions, I'm more than happy to answer them.